You have seen we have to describe a signal. So here we take a signal and signal of, in this we use f multiplied by 2 multiplied by 2 pi t. This is basically a sine signal. Now we have used plot. We have to use plot command to plot the output of the signal. Here we use one axis the time axis and the other one is the signal. We have used the sine axis. So when we apply this input, the signal shown to us is the sinusoidal signal in between time and sinusoidal. The second task is to add the titles and x and y labels to the existing task. So as we know, in previous task we have used define the time from 0 to 0.01 to 1, and frequency was 1. Here is the same frequency 1, and the signal is the same signal that we have used in lab task 1. So first of all we plot a signal, the common signal. So till this it is same like the task 1, but we have to add the title, the text labels and y labels to this task also. So to apply title, we use the command title plot of sine wave 1 Hz. This will plot the title of the output, and in x label we use time in second, and y label we use amplitude. Here we define the axis of x and y. Minus 0.05 to 1.5 is the axis of x-axis, and minus 1.5 to 1.5, as we can see in the output, minus 1.5 to 1.5, it is the interval of the y-axis amplitude. So when we apply this code in the command window, we see this output. We can see there is an interval of minus 0.1 to 1.5 is x, and minus 1.5 to 1.5 y interval. And here we can see we have here plot of sine wave. Title is given, and x y amplitude title, and y x label title is also given. So the output of this is sine wave also in this given interval of time. Now moving towards task number 3. Again here we use two signals. So first of all, the time is the same as we have used the previous signal, and as there are two signals, so we use two frequencies. F1 is equal to 10 and F2 is equal to 520. As there are two signals, we use separately to differentiate them. We use signal 1 and signal 2, so we can differentiate among them. First signal F1 frequency 10, it will use frequency 10, and signal 2 F2 520 frequency will be used. First we define the signal 1 and 2. Now we have to plot a signal. As you know, the command of the plot is t signal 1. This will plot the signal 1, and we have to plot the same signal on the same graph. So again we use t along signal 2. So the time is the same, but the signal 1 and 2 will vary. And now we have to assign the title. As you can see, the output plotting multiple signals in one figure, x label and y label. For axis, we have described the limits and time interval from 0 to minus 1. Here you can see from 0 to 1, and y 0 to 1. Minus 1 to 1. This is the interval, and we have seen this the title, and two signals are plotted on the same graph, and we have x label as well as y label. Now moving towards the lab task number 4. In this task again we have from the beginning we have the same, the time and frequency 1 and frequency 2, because two signals are taken. In signal 1 we have used frequency 1, and now we have to plot the signal in dots. So we have again used the plot command, but in addition with semicolon in dot. This will plot the signal but in the form of dot. Hold on, and again signal 2 will again we will plot a signal 2, and signal 2 R commands means the dots will happen but in the red color. And again we give the title to the task, and x label and y label, and axis as we know 0 to 1 in the x interval, and from minus 1 to 1 in the y interval. Here we can see the output. We have red and blue signals. The red one, the signals are the signal 2, and the blue ones are the of signal 1 as we have discussed in the code. Now moving towards lab task number 5. So in this task we have used the commits also. As you know that many codes we have to use this commit section so that the other users who uses the code easily can understand what we have discussed in the code. So in this task we have used the commits. For the commits we use it as percentage sign, and after the percentage what we write over here, it is in the commits. It is not a part of this part of the code, but basically it will help the user to understand what is happening in the code. First we have used written over to generate random data from a uniform distribution, and then again percentage and calculate the mean, plot the data and the mean. From here we can see what is happening in the code. We are taking the random number and taking the mean and then plotting the data and mean. So here n is equal to 50. Again percentage sign, we have given a comment here that 50 data points are there. Now random number we have assigned from n is equal to n 50 to 1. Plot command will plot the our signal, and mean we have taken the mean. Mean is an average also. We can also call average of the signal. Okay. Now we have to define the limits of interval from where to where we have to plot. Draw a line from 0 to m, and here is the command, and plot this to limit we use the command plot 0 to n, comma m to m, and hold off for the, and in the last we have used the title so there which appears at the top of the graph. Title is the mean of random uniform data. From the output we seen that the mean of this signal, the random